versus some measure of crime or GDP or income or patents, which people have said, like, how many patents does people in a city submit or get approved? It goes along this kind of straight line on this logarithmic plot. So this is another kind of scale-free distribution. And there's a lot there. People are trying to understand why this would be the case, why they all fit on this kind of plot. Yeah, so this is like there's more crime, there's a higher GDP, there's a higher income, there's a higher patent rate per person. It's not that there's more people, it's just per person. So cities are more, somehow per person, more active in all the good and bad things. So, this is the last one, distribution of Olympic medals in different countries. So, but this is all to show that these long-tailed distributions are incredibly common. I'm going to skip talking about why it explains this success of networks for a second. But one thing you can say is that these kinds of networks, while they're very robust to random node failure, if a random node fails, most nodes are don't have high connections, they're low degree, but they're very vulnerable to targeted hub failure. But they also can result in what's called cascading failure, where one node causes the failure of another node and so on. And we see that in power outages, like you saw the network of the power grid. But we also see it in things like bank failures, a similar kind of cascading failure, and other kinds of systems. Okay. So finally, what's interesting about this normal versus non-normal idea is that events in the tail in a normal distribution are highly unlikely. So this is like the height. So over here, the tail, there's very few individuals in these tails. Okay, and in fact, at some point, they become the probability is 0. And that's true for things like risk. This is a picture of volatility and risk in a financial portfolio. This is how you would model it with a normal distribution. But in these so-called long-tail distributions, events in the tail are more likely than they would be in a normal distribution. Okay. And we see that non-normal, that is these kinds of